Mathematics 2 End of Year Exam, 8th of May 2019. Question 5. The results of an experiment are given as follows. Time goes from 0 to 20 seconds and concentration goes from 60 down to 10 molarity. Part A, draw a sketch of the data. I'm going to answer this question using Excel. So first of all we need to enter the data. The time goes from 0, 5, 10, 15 and 20, and the concentration is 60, 40, 50, 35 and 10. And because it's Excel, let's insert a graph. So first identify the data and then go insert scatter graph points. Now looking at the graph, you can imagine a straight line running through the points somewhere like that. What we're going to do first is to calculate the Pearson Correlation coefficient. Excel has a built-in function to calculate the Pearson Correlation coefficient. So Pearson is there, double click on Pearson. For the first array we mark the cells, we put in a comma to say that's the end of the array. For the second array we mark the cells and then we close a bracket, and that gives us the Pearson correlation coefficient of minus 0.881. So that's a high value for a negative correlation, which is exactly what we'd expect because this data looks pretty linear and the gradient of a line that's going to run through those data points is going to be negative. So because we've got a high negative correlation, we can now go ahead and calculate the gradient and intercept of the line of best fit. To calculate the gradient, Excel has got an inbuilt function called slope. And the slope wants the known y's and then the known x's. Now, looking at the data, time goes from 0 to 20 in even steps, which implies very strongly that that is the independent variable. So that means that the concentration going from 50 down to 10 in rather irregular steps is the dependent variable, or the y. So we'll say that that's the y, comma, we'll say that the time is the x, close a bracket, and that gives the slope of the graph, which at minus 2.1 looks about right. It's a negative value, which is what we'd expect, and the time is going from 0 to 20 and the graph is going from 10 to 60, so double 20 is 40, so that's going to give us about the right value. And then for the y-intercept we use the function which is intercept, and again they want to know the y values, which are the concentration values, comma, the x values are the time values, close a bracket, equals that. So now we've got the Pearson correlation coefficient and the gradient and the intercept. So the final thing we want to do is to add the line of best fit. Because this is a straight line, we can say that y is equal to the gradient times the x value plus the intercept. So this value here is going to equal the gradient, which is minus 2.1, times the x value plus the y-intercept. Now the gradient, which is E45, and the intercept, which is E46, we don't want the E value to change, so we're going to put a dollar in front of those. And now what we're going to do is drag that across the bottom here and we get the points of the graph. So now we're going to click on the graph, select data, we're going to add a new series. I won't give it a name. The series X values are going to be time and the series Y values are going to be the values we've just calculated. And there you can see the points of the line of best fit, which run very evenly through the data. So going back to the question, we've drawn a sketch of the data, we've calculated the Pearson correlation coefficient. The correlation coefficient gave us good negative correlation, So we calculated the gradient and the y-intercept of the line of best fit, which are here. And then we've added the line of best fit to our graph, which is the orange points running down there. And then the final part says, state with reasons why you think your answer is right. The reason we think it's right is that the data is evenly spread about the line of best fit. And that's the answer to question 5.